For thousands of years, humanity looked to tradition for answers. Ancient authorities explained the universe. Religious institutions shaped understanding. Most people accepted the world as it appeared to be. The earth stood still. The heavens revolved above. And many believed that the great mysteries of existence had already been solved. But then, a revolution began. Not on battlefields, not in royal courts, but in observatories, laboratories, libraries, and workshops. A revolution powered by curiosity. A revolution driven by evidence. A revolution that would transform humanity's understanding of reality itself. This was the scientific revolution. Before the scientific revolution, knowledge often depended on authority. Ancient scholars provided explanations for nature. Many ideas survived for centuries without being tested. People relied upon tradition, philosophy, and inherited beliefs. Observation certainly existed. Innovation certainly occurred. But systematic experimentation remained limited. Questions were often answered through established teachings rather than direct investigation. Yet beneath the surface, curiosity continued growing. Across Europe, new generations of thinkers began asking difficult questions, and those questions would change history. The Renaissance created conditions that encouraged intellectual exploration. Ancient Greek and Roman texts returned to prominence. Education expanded. The printing press spread ideas more rapidly than ever before. Scholars gained access to knowledge from distant regions and earlier civilizations. Debate flourished. Critical thinking became increasingly important. A culture of inquiry emerged. People began believing that understanding the natural world required direct observation rather than unquestioned acceptance. The foundations of scientific thinking were forming. For centuries, many believed Earth stood at the center of the universe. The sun, moon, planets, and stars appeared to revolve around it. Then came Nicolaus Copernicus. Through careful observation and mathematical analysis, he proposed a revolutionary idea. The Earth was not the center. Instead, Earth orbited the Sun. This heliocentric model challenged assumptions that had dominated thought for generations. Its implications were profound. Humanity's place in the cosmos suddenly seemed very different. Galileo Galilei transformed observation itself. Using improved telescopes, he studied the heavens with unprecedented detail. He observed mountains on the moon, moons orbiting Jupiter, phases of Venus. Evidence accumulated. The universe appeared far more complex than previously imagined. Galileo demonstrated the power of direct observation. Rather than accepting assumptions, he looked for evidence. His work became one of the defining examples of scientific inquiry. The telescope revealed a universe larger and more dynamic than anyone had expected. Johannes Kepler expanded humanity's understanding of planetary motion. Through careful analysis, he discovered that planets move in elliptical paths rather than perfect circles. This insight improved astronomical accuracy dramatically. The heavens were not governed by philosophical ideals. They followed measurable patterns. Mathematics became a powerful tool for understanding reality. nature appeared increasingly understandable through observation and calculation. The universe seemed to operate according to discoverable laws. Perhaps the most important development of the scientific revolution was not a specific discovery. It was a new process, the scientific method. Observe, question, hypothesize, test, analyze, repeat. Rather than relying solely on authority, knowledge became something that could be investigated, challenged, and verified. This approach transformed every field of inquiry. Science became a self-correcting system, a method for gradually improving humanity's understanding of reality. Few individuals symbolize the scientific revolution more than Isaac Newton. Building upon the work of earlier thinkers, Newton developed principles that explained motion, force, and gravity. An apple falling from a tree, the moon orbiting Earth, planets moving through space. All could be described through universal laws. For the first time, humanity possessed a framework capable of explaining both earthly and celestial phenomena. Nature seemed understandable, predictable, mathematical. Newton's achievements transformed science forever. His influence continues to shape modern understanding today. The scientific revolution reached far beyond astronomy and physics. Medicine advanced, engineering improved, navigation became more accurate, technology accelerated. Scientific thinking influenced education, economics, and government. Knowledge expanded at an unprecedented rate. Humanity gained new tools for solving problems. The consequences would eventually reshape civilization itself. The modern world was beginning to emerge. The scientific revolution was more than a collection of discoveries. It was a transformation in how humanity approached truth. Questions became opportunities. Evidence became essential. Curiosity became a force capable of changing civilization. The thinkers of this era challenged assumptions that had stood for centuries, and through their courage, humanity learned something extraordinary. The universe could be understood, not all at once, not perfectly, but step by step, discovery by discovery, question by question. This was the scientific revolution, the moment humanity changed the rules of knowledge. And perhaps the greatest legacy of the scientific revolution is that it never truly ended. Every modern laboratory, every telescope, every spacecraft, every medical breakthrough, every technological innovation exists because generations of thinkers chose to ask questions. The scientific revolution reminds us that progress begins with curiosity, and that some of humanity's greatest achievements begin with a simple willingness to wonder, what if we are wrong? And what might we discover if we look again?